welcome to TV Elimu Live program, where we bring you live lessons to help you learn while you're at home during this period. We welcome you for our lesson today. We are handling mathematics lesson for Form 4s. We are handling Form 4 mathematics lesson. That is mathematics lesson for Form 4. And for Form 4s, we are aware of how to prepare for the exams. You will realize that when you step into high school, by the end of the 4 years, you sit for an exam, and you sit for 2 exams, that is paper 1 and paper 2. You are aware that each of the paper counts to the final score and in obtaining your final grade. And so they are all important, and you need to revise all of them when the exams time comes. And so I will help you to look at the main aspects that we discuss in paper 1 and how to revise for the mathematics paper 1 exams. Even before we get into the content of what is required of you, it's important as a candidate that you need to understand being in a mathematics class or preparing for mathematics lesson requires you to be prepared with the requirements that are necessary to help your revision and to make it easier for you to get into what is required and advance further on the concept that you are supposed to learn and also to understand. Therefore, what do you really need to have before you start the preparation process? One, as a student and as a candidate, you are required to have, number 1, you must have your calculator. You must have your calculator, which will help you when carrying out arithmetics and calculations that may take time if you didn't have this instrument. Number 2, we expect you to have a geometrical set. We expect you to have a geometrical set. For construction purposes, you will need to have a geometrical set. Number 3, as a candidate, you must have your mathematical table, because you'll find their concept that require the use of mathematical tables, or you will have to use some formulas which are written at the back of your mathematical table. Therefore, a mathematical table is an important requirement when you are preparing for the exams. And then number 4, for the case of drawing, you will require to have a graph book. You will have to have a graph book with you. You will need to have a graph book with you, and the basic one, which is to have your exercise book. You must have an exercise book and your pens. You must have an exercise book and your pens. Therefore, do not get into any preparation or into any exam for mathematics if you don't have these 5 items. The first 3 items, the calculator, the geometrical set, and the mathematical table, are necessary and they are required even during the exams. Therefore, you'll be required to get to the exam room with your calculator, with your geometrical set and the instruments, and the mathematical table, plus your pens. The other ones, which is the graph book and the exercise book, will only be necessary for you to carry out a revision so that you are able to follow track on what you are revising on. And it's always important to have the right reference books and the right textbooks that are recommended to help you revise on those areas that you'll be revising on. Therefore, when we get to the exam preparation, we've agreed that there are 2 papers. There is mathematics paper 1 and there is mathematics paper 2. For today, we are discussing the concepts in mathematics paper 1, which are majorly Form 1 and Form 2 work. And as you will realize that mathematics paper 1, the mathematics paper 1 is about 75% of the content. 75% of the content will cover Form 1 and Form 2 work. 75% of the content will cover Form 1 and Form 2 work. And the remaining 25%, will cover Form 3 and Form 4 work. Therefore, it is easier to tell that as a candidate, if you want to do well in paper 1, you must have to put a lot of emphasis on Form 1 and 2, even though Form 3 and 4 will still count in that paper. Out of this 75%, the lion's share of the score or the marks in paper 1 will come from Form 2 work. So about 50% of this 75, about 50% of it will come from Form 2 work. And the remaining 25% or thereabout of this work will come from Form 1 work. Therefore, it tells you that Form 2 contributes a lot to your paper 1 scores. When talking about the Form 2 work, we are talking about a total of 20 topics. Total of 20 topics covered in Form 2. And Form 1, we are talking about a total of 23 topics that are covered in Form 1. But not all of them will be examined, but we shall have to integrate few concepts from each of the topics so that by the end of the 4 years, all the areas should be covered and should be examined, either directly or indirectly by integrating the concepts into other topics. And it is quite simple and easier to see that once you've looked at Form 1, the same concept are extended to in Form 2, and so you get to know that what was taught in Form 1 is a foundation of what will come in Form 2, Form 3, and Form 4. And that's why it is easier to bring them together as in an integrated form to come up with a final standard exam that can now be able to produce, to give us a clear picture of where you are and what you've been able to do for the 4 years. So in our lesson, I want to welcome you students that will discuss this paper and see how well can we prepare for this paper and in which areas do we need to put more emphasis on when we are preparing for the mathematics paper 1 exams. First of all, you need to understand that this paper, just like paper 2, it has 2 sections. It has section 1 and it has section 2. Section 1 and section 2. When talking about section 1, these are short structured questions from question number 1 all the way to question number 16. Question 1 to question number 16. And this section has 50 marks. It has 50 marks, and the instructions are you answer all the questions. You answer all the questions. Question 1 up to question 16, there are short structured questions that will be answered, all of them as the instructions provides. Section 2 of this paper, again, it contributes 50 marks. It contributes 50 marks from question 17 all the way to question 24. But we don't answer all of them. The instructions are we answer any 5 questions. We answer any 5 questions. Each of the questions in section 2 has 10 marks. Each of the question has 10 marks. And therefore, when you answer 5, you'll have answered a maximum of 50 marks. And so 50 plus 50, then your final score will be 100 marks. And these are the sections that we are saying that cover content majorly from Form 1 and Form 2 work, as we shall be able to highlight. Our basic thing today is to be able to discuss now specifically what are the components that constitute to this kind of paper, and how then do we go about it. I will give few concepts for section 1 and few highlights for section 2 so that you get to know what are the common topics in section 1 and what are the common topics that will contribute to section 2. So our first classification, therefore, in section 1, we will be able to discuss a concept where we apply the use of body mass. The use of body mass. We have to understand the concept on the use of body mass. And as candidates, we are also conversant with what is body mass and how to apply body mass concept. And we all know B stands for brackets, O is off, D is division, M is multiplication, A is addition, and S is subtraction. In your syllabus, therefore, what are these topics that majorly focuses on the use of body mass? These are Form 1 topics. We have the topic we call integers. We have what we call integers. Our topics here, we have integers, we have fractions, and we have decimals, and we have decimals. And they are all covered in Form 1 work. These topics are quite simple, and this concept is again quite simple because students have developed the concept all the way from primary school to high school, where then it becomes easier for them to remember and apply when they are working out questions on use of body mass. But however, I want to remind you one thing, that these questions on body mass are usually covered in 2 parts. You will find that there is a question that requires you to apply the concept of fractions, where you are given both the numerator and the denominator, then have to work it out with the numerator first, work it, and then work it with the denominator separately from the numerator, and then combine your solution so that you can come up with a final answer. So to illustrate this, let's look at a case question. Let's look at a question here and see what we mean by this. We are told to evaluate negative 16 divide by 4 plus 6 times 14 minus 2 times minus 5 over 84 divide by 14 times 3. Divide by 14 times 3. That is a question from integers. When see such kinds of numbers, these are integers, because an integer simply refers to a negative whole number, a positive whole number, or 0. So which are represented here clearly in our example. If we are to work out this question together, students, we have to separate the numerator and the denominator, so that we have the numerator part, which has negative 16, we divide by 4 plus 6 times 14 minus 2 times minus 5. And so we apply body mass. In our case, body mass, we don't have the brackets. So we'll start with division, which is negative 16 divided by 4. So students, what is negative 16 divided by 4? Yes, the answer is negative 4. Negative 16 divided by positive 4, it's negative 4. Then we bring it down again and say, instead of negative 16 divided by 4, we write negative 4 plus 6 times 14 minus 2 times minus 5. So we are done with division. Next is multiplication. So what are we multiplying, students? We are multiplying 6 by 4 and negative 2 by negative 5. So we'll write 6 times 14. This gives us 84. And then the other side you have negative 2 times negative 5, which gives us positive 10. Negative 5 times negative 2 is positive 10. And then 6 times 14, that gives us 84. Therefore, we combine this together then to have negative 4 plus 84 plus 10. Negative 4 plus 84 plus 10. This will give us negative 4 plus 94, which is 90, which is 90. So our numerator part has a solution of 90. Then extract the denominator as well. Our denominator has 84 divided by 14 times 3. 84 divided by 14 times 3. So students, what do you start with? Yes, our first step is to do division, which is 84 divided by 14. 84 divided by 14. What is 84 divided by 14? Yes, 6. The solution is 6. And so we will have 6 times 3. What is 6 times 3? 18. 6 times 3 is 18. Good. Therefore, you take the numerator and divide by the denominator. So our final solution will be 90 divided by 18. 90 divided by 18. What is 90 divided by 18, students? 18, 1, 18 here is 5. So the solution is 5. We shall have worked out clearly the use of body mass, and in this case referring to integers. Number 2, we can have the same concept, but now we apply decimals. And usually when we are asking students to apply decimals, we give a concept that is in line with this kind of example as our question number 2, and you are told to evaluate without using tables or calculators. Tables or calculators. You evaluate without using tables or calculators. You evaluate 0.125 times 0.343 over 0.0049 times 0.25. 0.125 times 0.343 divided by 0.0049 times 0.25. Very clearly from decimals. So therefore, what do we do in this case? Yes, our solution will be, we write as it is 0.125 times 0.343 over 0.0049 times 0.25. So students, where do we start from? Good. We count the number of decimal places from both the numerator and the denominator. And so in the numerator we have 1, 2, 3, 4, 5, 6. So there are 6 decimal places. In the denominator, 1, 2, 3, 4, 5, 6. Again, there are 6 decimal places. So what do we do next? Yes, we multiply by the total value equivalent of the number of decimal places with the highest number, and because they are all the same, we shall multiply all of them by 1 million. Again by 1 million. Multiply by 1 million. The 1 million, or the 6 places, takes out the decimal places from both. So what do we have? 125 times 343 over 49 times 25 over 49 times 25. What is our next step, students? Yes, we cancel by looking at the common factors, and you'll be able to see 25 is 1, 25 into 125, 5 times. Then 7 into 49, 7 times. 7 into 343, that is 4 because of 28, into 63, that is 9. Then what else? It has 7, 1, 7, 7. So what is our solution? 5 times 7. What is 5 times 7? 35. 5 times 7 is 35. So we shall have evaluated this without the use of tables and calculators. Students, make sure when you're working it out, you show the cancellation, because that is what then can be able to confirm that you're not using the calculators as it has been given in the instructions. That is our second item that we need to focus on the use of BODMAS. We concentrate on the decimals. And again, there are cases for the fractions that you can also look at and see how you apply BODMAS on fractions and so on. So that is our first area when we are revising Form 1 work to cater for paper 1 exams. We'll go to the second concept, and our concept number 2 is based on angles. And in Form 1, we have a topic we call angles and plane figures. That is the topic that we have for angles in Form 1. Topic, angles and plane figures. Angles and plane figures in Form 1. Again, to our students who are watching us, wherever you're watching us from, this is KUTV, Elimu Live, and today we are discussing mathematics for Form 4, particularly discussing how to go about the preparation for an exam in mathematics paper 1. And we are discussing Form 1 concepts that relates to mathematics paper 1. Our first item was based on the use of BODMAS, and we've discussed about integers, we discussed about decimals and fractions. Our second item is angles, where we are saying the topic in Form 1 about angles is what we call angles and plane figures. Therefore, we need to know how do we respond to angles in plane figures when you are given a question from that part. So we will have a question to illustrate that, and that will be our question number 3. Our question number 3, which is, you're told the interior angle of a regular polygon is 3 times the exterior angle. Find the number of sides of the polygon, and hence state the name, and hence give the name of the polygon, of the polygon and hence give the name of the polygon. That the interior angle of a regular polygon is 3 times the exterior angle. So you find the number of sides of the polygon and hence give the name of the polygon. Hence give the name of the polygon. So where do we begin, students? Yes, we will need to understand what is the exterior angle and the interior angle in this case, and know what is the relationship between the exterior and the interior angles. So we start, in our case, the interior is 3 times the exterior. So which one is smaller? Yes, our smaller angle is the exterior angle. So we give the exterior angle the unknown letter. We say we let the exterior be x. Or use any letter. You can use y, you can use t, r, whichever letter that you want to use, as long as we are able to form an expression that relates both the interior and the exterior angle. So if the exterior angle is x, then what is the interior angle? Yes, the interior angle is 3x. Good. Our interior angle will be 3x because the interior is 3 times the exterior. Now, what is the relationship between the interior and the exterior angle, students? Yes, if you have the interior angle, the interior plus the exterior angle, you will always get 180 degrees because these angles are on a straight line. They are straight angles. Therefore, interior, which is 3x plus x, will give us 180 degrees. So what is 3x plus x, students? Good. This is 4x equal to 180. And how do you get x? We divide by 4. Divide by 4. This cancel out. And so we have 2 is 2. 2 into 180. 90. 2 is 1. 2 into 90. 45. So it is 45 what? Degrees. Therefore, one exterior angle is 45 degrees. One exterior angle is 45 degrees. The question is, we find the number of sides and hence give the name of the polygon. So what do we do to get the number of sides? Yes, number of sides equal to 360 over the exterior angle. 360 over the exterior angle. So what is it? 360 degrees. What is the exterior? 45. 45. So students, what is 360 divided by 45 using your calculators? Yes, we said we should have calculators in a mathematics class. What is 360 divided by 45? 45 is 1. 45 here, this is 8. So it is 8 what? 8 sides. Therefore, the polygon has how many sides? 8 sides. Good. Now, what is the name of this polygon? What's the name of a polygon with 8 sides, students? An octagon. Good. The name is an octagon because we say that polygons are named based with the number of sides that they have, and we gave the names of polygons in Form 1 and said that based with the number of sides the polygon has, we obtain names. So we have the number of sides, and then the name of the polygon. Name of the polygon. name of the polygon versus the number of sides. So let's remind ourselves, how do you call a polygon with 3 sides? Because that is the lowest number. How do you call a polygon with 3 sides, students? Yes, this is called a triangle. This is called a triangle. I have 4 sides, students. 4 sides. Good, a quadrilateral. And why not a rectangle? Why not a square? Squares, rectangles, parallelograms, rhombus, those are part or examples of quadrilaterals. Kwa hivyo, a polygon with 4 sides is called a quadrilateral. 5 sides. How do you call a polygon with 5 sides? Good. Pentagon. Pentagon. 6 sides. How do you call a polygon with 6 sides, students? Good. Call it a hexagon. Hexagon. What about 7 sides? Heptagon. Good. Heptagon. 8 sides. We've mentioned it here. Octagon. 9 sides, students. Good. Call it a nonagon. And 10 sides. Yes, we call it a decagon. Good. Decagon. So those are the names of other polygons that we will need to know in Form 1. Again, students, also understand that apart from just looking at the interior angle and exterior angle, we also need to understand that we have a way of determining sum of interior angles. You may be asked to determine sum of interior angles. Sum of interior angles. And so how do we get sum of interior angles of a regular polygon? We get it by 180n less 360. 180n less 360, where n is the number of sides. Number of sides. Where n is the number of sides. Therefore, that is our second item in Form 1 under category we call the angles. And so we can go to the third one. Our third area that we need to look at again when looking at paper 1 is now based on Form 2 work, and that is what we call trigonometry. Number 3, we have trigonometry. Trigonometry, that is now Form 2. You will remember that we have trigonometry in Form 2, trigonometry in Form 3, and trigonometry in Form 4. Each of the forms depends on each other, but the foundation line is trigonometry in Form 2, where we discuss few concepts on that topic. So I will give an example for us to be able to see how we respond to questions on trigonometry, and that will be our question number 4. Our question number 4, and you are told, given that sine A equal to 3 over 5. Find cos A without using tables or calculators. Without using tables or calculators. Without using tables or calculators. Given that sine A is 3 over 5, find cos A without using tables or calculators. Again, what is key here is for students to understand that in trigonometry, specifically Form 2 trigonometry, we apply the concept we call SOHCAHTOA. We apply the concept we call SOHCAHTOA. What do we mean by this word? S stands for sine. So sine is the opposite over the hypotenuse side. C is cosine. Therefore, we say cosine is the adjacent side over the hypotenuse side. T stands for tan. Therefore, tan is the opposite side over the adjacent side. For students who don't understand what we are meaning, if this is a triangle and this is right angle at this point, this is our angle A, then the line at the base is what we call the adjacent side. This is the adjacent. This side, which is opposite to the angle A, is called the opposite side. And the longest side is called the hypotenuse side. That's why we are saying when we talk of sine, sine is the opposite over the hypotenuse. But again, you need to understand where is the angle. If we change the angle from this point to this point, then now the opposite to this angle will become the adjacent. So there are cases where the opposite and the adjacent interchange each other. And that depends on where is the angle located. So if we've been given that the sine of the angle A is 3 over 5, it means the opposite is 3 and the hypotenuse is 5. So we need to get what is the adjacent. We need to get what is the adjacent. So what do we apply to get the missing side, which is the adjacent, students? Yes, we apply Pythagoras theorem. So applying Pythagoras theorem, if we apply Pythagoras theorem, then it means the adjacent side squared plus the opposite side squared will give us the hypotenuse side squared. Therefore, what is the adjacent? It is x squared plus 3 squared is 5 squared. We collect the like terms. This means x squared plus 9 is 25. So we take 9 to the right side, therefore x squared is 16. And how do we get x, students? If x squared is 16, what is x? Good. X is the square root of 16, which is 4. It means, therefore, our adjacent side is 4. So our adjacent is 4, our opposite is 3, and the hypotenuse is 5. And finally, what is cos A? Cos A is from our SOHCAHTOA. Cos is adjacent over the hypotenuse. The adjacent over the hypotenuse side. What is the adjacent, student? Yes, the adjacent is 4 and the hypotenuse is 5. Therefore, our answer is 4 over 5. So our answer is 4 over 5. So shall I have worked out the question number 4 using SOHCAHTOA. Good. Another thing that we will need to discuss again is this concept, question number 5. And question number 5 is that given that cos 2x minus sin x equal to 0, given that cos 2x minus sin x equals to 0, find the value of x. Find the value of x. given that cos 2x minus sine x equal to 0, we find the value of x. We find the value of x. So where do we begin? Yes, we have to look at these two in this case, that cos 2x is minus sine x equal to 0. So if I take sine to the right side, it means that cos 2x equal to sine x. And so at the point where cos and sine are equal, then we relate to what we call complementary angles. They are complementary angles. So students, what are complementary angles? Yes, complementary angles are angles that add up to 90 degrees. And the other type of angles, we call them supplementary. If they are supplementary, they add up to, yes, 180 degrees. But for the case where the cos and the sine are equal, it means that these angles are complementary. So what do? 2x plus, the angle here is x, we equate it to 90. So 2x plus x equated to 90. Good. What is 2x plus x? Yes, 3x equal to 90. 3x is equals to 90. How do you get x? Good. We divide by 3 on both sides. Divide by 3, divide by 3. This cancel out. And x equal to, what is 90 over 3? Yes, 30 degrees. Therefore, our value is 30 degrees. That is how we look at trigonometry 1 for the purpose of paper 1. Our next concept that we need to analyze, students, as number 4, and to those who are joining us now, we are having our lesson in mathematics for Form 4, but we are taking at a review for the exams, and that means that we look at from Form 1 all the way to Form 4, but specifically for our lesson, we are revising Form 1 and 2, which is majorly what covers paper 1 mathematics. So we are on item number 3, which is about trigonometry, and trigonometry is covered in Form 2 work. And so the next item, which is number 4, is an item on what we call equations, with a classification on equations, which is again important when we are discussing paper 1. So when looking at this kind of classification under equations, then we have quite a number of topics under equations that we shall need to look at. So that is equations. That is our item number 4. And under equations, we will discuss the following. We'll discuss gradients and equations of lines, gradients and equations of lines, which is a concept in Form 2. We will discuss what we call the linear equations, a concept in Form 1. We will discuss linear inequalities. Linear inequalities is a concept in Form 2, and then we have matrices, which will give us a concept again in Form 3. Those are the areas that we will look at. So we will try to look at each one of them and use questions to illustrate what we've done, because it's a revision class. And so that will then be our question number 5. To illustrate this. And so we are given a question. You're told to determine the equation of a line, passing through, determine the equation of a line passing through -1, 4, and negative 1, 4, and perpendicular to the line 2y minus 3x equal to 4. Perpendicular to the line 2y minus 3x is equals to 4. That is what we have as our example to determine the equation of a line passing through negative 1, 4 and perpendicular to the line 2y minus 3x equal to 4. Therefore, students, we need to understand when you're given such kind of a question, where do we start from? And we always have to get the gradient first before we get the equation. Therefore, we need to know how do you get the gradients of lines. There are only two ways. One, either the change in y over the change in x, and that happens if we've given you 2 points on the line, or we rewrite the equation in the form y is equals to mx plus c and obtain the gradient, which is the coefficient of x, or the value of m. In our question 5, it's only practical to make this equation in the form y is equals to mx plus c and then obtain the gradient from there. So we'll start by the equation given, which is 2y minus 3x equal to 4. We take 3x to the right. When 3x crosses to the right, it becomes positive. So we'll have 2y equal to 4 plus 3x. 4 plus 3x. So what do we do next? We divide by 2, by 2, by 2. This cancel out, and y equal to 4 divided by 2 is 2 plus 3 over 2x. Plus 3 over 2x. Therefore, what is the gradient from this equation? Yes, the gradient is 3 over 2, the coefficient of x. That becomes our gradient 1, 3 over 2. Then number 2, the lines are perpendicular to each other. The lines are perpendicular to each other. So if they are perpendicular, students, what do we do? Yes, we say if they are perpendicular, then it means that gradient of line 1 times the gradient of line 2 will always give us the negative 1. To always give us negative 1. Gradient of line 1 times gradient of line 2 will give us negative 1. In our case, our gradient 1 is 3 over 2 times m2 is negative 1. So what do we do next? We multiply by 2 over 3. Multiply by 2 over 3. So this cancel out, this cancel out. Our second gradient is negative 2 over 3. Our second gradient is negative 2 over 3. So what do we do next, students? Yes, we use the given point and a general point x, y. So we use negative 1, 4 and xy. Xy is the general point. Okay, with these 2 points, how do you get the gradient, students, again? Yes, change in y over change in x. So it will be y minus 4 over x minus 1. And we equate this one to negative 2 over 3. Then what's the next step? We cross multiply. This is 3 into y minus 4 equal to negative 2 into x plus 1. Why is it plus? It's negative, negative. That is plus. Then we expand this to have 3y minus 3 by 4 is 12. Negative 2 by x, negative 2x. Negative 2 by 1, negative 2. Then collect like terms. This to the right side with 3y equal to negative 2x. Now, what is negative 2 plus 12? Plus 10. Good. So we have to give the equation in the standard form, which is y is equals mx plus c. And how do we get that? We divide by 3 on both sides. This cancel out, and y equal to negative 2 over 3x plus 10 over 3 is 3 and a third. 10 over 3 is 3 and a third. And that is the equation of that line, which is passing through negative 1, 4, and it is perpendicular to the line 2y minus 3x is equals to 4. Do not forget again, apart from being perpendicular, we can have lines that are parallel. And if the lines are parallel, you will need to know that such lines have the same gradients. If you are told that the lines are parallel, if the case was for parallel lines, if the lines are parallel, then we shall say that the gradients are equal. Gradients are equal. And that is the concept we say that the gradient 1, m1 is gradient 2, m2. And the process will still be the same. Again, remember that if you are not given the points, maybe you may be given the equations. We've strictly said first, write the equation, the form y is equals mx plus c, and then use that to be able to illustrate what is the gradient and so on. Number 6, need to get question 6. Again, from the equations, need to get question 6. Question number 6, you are told to solve the inequality. Solve the inequality 2x minus 1 less than or equal to 3x plus 4 less than 7 minus x. Less than 7 minus x. Linear inequalities, quite important as well. But now when you're given a compound inequality, students, you need to understand how to separate the inequalities to have one simple linear inequalities. So we need to get to separate these two. From this point, all to the way to where the second inequality starts, that becomes the first inequality, which will be 2x less 1 less than or equal to 3x add 4, and solve that equation, that inequality I mean. We solve the inequalities by collecting like terms, just like the linear equations, but do not substitute the inequality sign by the equal sign. Let them be able to remain the same inequalities signs. This to the left and this to the right. So we'll have 2x less 3x less than or equal to 4 plus 1. So 2x minus 3x gives us negative x less than or equal to 5. Because 4 plus 1 is 5, students. So how do we get x? Remember, this is negative 1x. Therefore, we divide by negative 1 by negative 1. And any time you divide or multiply an inequality by a negative number, the inequality sign changes. Therefore, in this case, we will have x not less than or equal to, but now becomes greater than or equal to negative 5. Again, we take the second inequality, which then turns from the last point all the way up to the second inequality from the right. And so we'll have 3x plus 4 less than 7 minus x. Again, we collect the like terms, bring the x to the left, and take 4 to the right. When negative x comes to the left, becomes 3x plus x less than 7 less 4. 3x plus x is 4x less than 7 minus 4 is 3. So we divide by 4, divide by 4, this cancel out, and so our x is less than 3 over 4, which is 0.75. And that is our solution for the linear inequalities. So we can look as many areas as we can, but because of time, we will stop there and allow you also to keep on revising on the 5 areas we've listed using the 6 questions that we've discussed in our lesson today. That has been basically to help us review most of the paper 1 concept, and we are saying that this paper is simple. It contains most of the marks from Form 1 and Form 2 work. So until next time, when we shall meet again for another lesson to revise on the same paper 1, I've been your teacher, Mr. Ndenga Elphys. Goodbye.